Okay, you're looking at the FlipDB session, which looks suspiciously like your Dyalog session, but it's not. It's its own application. Of course, it runs in Dyalog, and I'm just going to jump right in here. FlipDB is, I realize now, I didn't realize when I started it, but it's a programming language, and as such, it has nice things like 0, which are useful for programming, and 1, which is also useful. And you can do things like that, which is also useful. So FlipDB at its basic level is a programming language. And our data type, our basic data type, we call it a column for reasons that you will see, which should become clear. And a column is just basically our version of an array. And they may be scalar, and we have types like decimal, and they may be date, we have types like date. And they may be character, and they may be, notice that character is actually a scalar thing. It's one thing, even though it's a string of 4 characters. Whoops, took a little too much there. You can have, let me do that again. You can have simple columns, which are essentially vectors, but we display them as columns, again, for reasons that will become apparent. And let's see. We have enclosed columns, enclosed arrays, and that's just using a function to actually create that. And we have partitioned columns. And the reason we display this partition and these enclosed columns as you see them there is so that if you have a simple column, it lines up nicely with an enclosed column. So if this was data in a database and you had 3 rows and one column had 1, 2, and 3 in it, and another one might have some nested data, it all lines up nicely, and you can see what's going on in the display session. And there is scalar extension, as you would expect. You can do things like that. Functions take columns as arguments, just as you would expect. And they return columns as results. And they're the usual scalar functions, so we can do things like that. And we can do things like that. And there are aggregate functions, sum, average. And there are hybrid functions, which are a little bit like scalar functions and a little bit like aggregate functions. They're like scalar functions in that they return a value for every value of your input, but they're like summary functions in that they are dependent on other items in the column or in the array. And we all know these as APLers, but we don't really call them that. Whoops. Do that. Plus scan is a hybrid function, and scan is a hybrid function. So we have all those things in there. Assignment is done using the equals sign, and the fact that we're using ASCII symbols for everything in this language in no way indicates that I think that we should go that way with APL. That's a separate issue. I'm very happy with APL symbols myself. So we can do assignment like that, and we can do things like that. So we have A and we have B, and we can run little functions like that. Now, in addition to a programming language with columns or arrays, if you will, and functions, there is a built-in database which is exposed via an object model right in there. So we can, at the top of this object model is a server object, which has a bunch of databases in it. And this server could be local, it could be remote, and you would interact in this session in exactly the same way if it happened to be remote or it happened to be right on your machine. And the server object has a bunch of methods, one of which is to delete a database, And I'm going to delete this little database called S&P so I can start with a fresh, clean copy. And there's a built-in method actually called create the suppliers and parts database. This is a very long-standing database of very small, 3 little tables that if you've read anything about databases by C.J. Date or E.F. Codd, some of the major founders of relational theory, they always use this little example, and it's quite useful to have it built into the system so you can do everything from unit tests to little presentations like this. So we'll take a look at this database. There's the result of this is a database object. So you can we have a server object, and then server you can extract a database object. From a database you can get a table object. So here I'm going to get the suppliers table, which is called S, and this we'll take a look at it. And with this table object we can execute a trivial query, which is just going to query all the rows and columns, and we can display that. And the supplier table lists 5 suppliers, their names, a status, which is meaningless, but just a little integer to play around with, and the city where that supplier resides. We can extract a column from this table using the getColumn method. And then we can play around with it just as we played around with the literals that I typed in a few minutes ago. So I can do things like that. Notice a double equal sign because equals is used for assignment. So you use equals equals for equality, just as you do, I think, in C# and whatnot. We can run a little more interesting query using this execute query method on this table, where we select some rows where the status equals 30, and we select some particular columns. It's a little more interesting. And let's also now grab out the parts table and run a little query to bring that in and display that so we can just see what data we're dealing with. So we have a supplier table and a parts table. And there's a cross-reference table as well, suppliers and parts, which links these all these together. So supplier number and part number are foreign keys that point to the supplier table and the parts table respectively. Now, queries are complicated things. In fact, as Dave Thomas talked about yesterday. And while certainly they're so complicated, I mean, you can simplify them as much as you can. A lot of people still aren't going to be able to write queries because it's like writing APL in it's a functional or what's the word I'm looking for? Not procedural, but declarative way of programming. So no matter how easy it is, it's not always easy to do. But the constructing them is a real pain, even if you really know what you're doing. So in order to do this, you can't just take a little method like query and string out everything you might want to throw in there on it. You'd have an argument from here to California to do that. And it's hard to visualize it and see it and edit it. So we have an object. We have an object model. Let's have a query object. We can set some properties, use some methods to build up a complicated query. And the way we do that is just to get a query object from a particular table. So here I have a query object Q that's extracted from this table. And that means that the suppliers and parts table where I extracted this query from is going to be the starting table for the query. So this is a query object. It's not the result of a query. And we can look at this query by just typing Q. And if we do that, it displays it. And we can see that the starting table is the suppliers and parts table. We have not specified a where clause. There's no where quota. There's no grouping. These are all default values, okay, for the properties of this query. And let's set some properties now. One of the things we can do is we can specify the select property, which is going to define all the columns that we want in our result set. And in this case, I'm setting it explicitly with 3 columns. Now, anything besides a trivial query will often have dozens, if not hundreds, of columns in the result. and they're often complex expressions. And stringing it out again, all one line, is very hard to read. So there's a helper method which we can use, the add column method of the query object, to not only write an expression, but actually name the column. So if we want to explicitly name a column, we can do that. And if we look now at our query .select property, there are the three items that I added initially, where the name and the expression are the same. And then we have this weight column. And also, the expression for that, pno.weight, is looking at the foreign key for the part number and jumping into, because that's a foreign key, we are jumping into the parts table, getting the weight column from the parts table, bringing it into the suppliers and parts table, and there's a many-to-one relationship, so it will expand it and line it up and do everything that we need to do there. So there's no explicit joins. All the joins are implicit. We can add another column, extended weight, which is weight times quantity. So notice there that we are using the fact that we just defined quantity, or we just defined weight one line above, and now we can do this. And let's run the query, and there it is.
Now, is that extended weight that's calculated, stored, and then withdrawn in the query, or is that just a calculated function that gets executed every time?
It gets executed every time. If we look at the query object, it's a program, and when you run the execute method, query.execute, which we just saw, it runs this program. And the heart of the program is run these expressions with those names and return the result. So as we're adding all this stuff to the query, nothing is happening. We're just collecting up all these arguments. When we do q.execute, we're going and we're running through this and we're doing all this stuff. And again, it might be on your local machine. It might be on a remote machine somewhere. We can do a lot more in a query. We can specify that we want to group the results. So here I might want to group by the supplier number. And I'm going to assign the result so I can use it later. And that just stands for something. I forgot what so here I've grouped, but I have not summarized the data. My query has not changed. I changed the grouping on the query, but I didn't change any of the select statements. So what have we done? We've just took what we did before, but instead of we've grouped the data so that we have unique supplier numbers instead of the entire table. So we've grouped by supplier number, but we have not summarized. In SQL, you generally have to do the two at the same time, but they're independent here. We can now summarize this data by clearing the select property, because the select property before had all these expressions in it that didn't do summaries. They were just straight across the table. And we can add some summary columns to our result. Total quantity and the total weight. So we just done some summing, some counting, some summing, and we've actually done a sum with on the quantity times the weight to get the total weight. Right? Now, what you're seeing, the result of a query, is a data table, which is distinct from a table. Table is actually a physical has a physical presence on your disk. A data table is an in-memory table that is the result of a query or created from scratch, or any in-memory representation of a table. To display these things, we have yet a third type of table, which is a report table, which is all text and displays things in nice ways, and useful in the session. But a report table is also, and we'll see that later if we have time, the vehicle for very rich formatting, shading, gray shading, borders, all the things that you might want to do in a PDF or in a rich text file, or presentation quality reports. But I use it in the session, so we have nice formatting. Now let's add some more interesting statistics to this little query. So I'm using the add column method of the query to add a bunch of statistics, and we're going to execute that. And this is just a representative sample of some of the things that you can do. The first one there is simply calculating the parts percentage, and that adds up to 100 if you look down the column, and that's just taking the total quantity column and dividing it by the sum of the total quantity. And then I multiply it by 100 and round it, so it's a nice decimal number. The second one, red parts, is interesting. I'm summing the quantity, but only where the color is red. And that's a useful little technique there. The third one, most supplied parts, a little more complicated. I want to find what is the most supplied part for each of these suppliers. And we're using a grade down function, and you can probably guess what that does. And we're using an index function, and you can probably guess what that does. But in order to make it a little clearer, I just put a little extra stuff in here. I can extract the quantity column from this query result, and we can take a look at it. And remember, this is group data, so there it is. And when we're referring to it up there in the when we're referring to it up here in the calculation, it's a grouped entity. I mean, it has there's structure to it. It looks like this, and we can sort that. We can extract also the part number. Take a look at that. I'm basically going through this step by step, how that calculation was done. And then we can use that to index in. And then we can take the first on it. So that's how that's done. And from an APL standpoint, it's all, you can imagine what's going on under the covers. It's all trivial, really. So when you think about a query, it really is a program. And it's a program that you can construct and then execute. And it just steps through it sequentially. There's a couple of other interesting properties for these queries that you can see on the screen, but that we haven't played with yet. And one of them is we can remove, you'll notice that there were some empty groups in that query. The last item was empty. So there's a property to keep them or remove them. So we can rerun that query now, and we've gotten rid of that last line. Because often you do not want the empty groups. Often you do want the empty groups. If you're ever doing reporting and you need to show that there are in fact no loans in the state of California, you have to show that. You can use the order by property to sort the results in any way you want. And the sorting is done when you order by, it's done after all of the grouping. And the display of the query is an indicator of the order of operations. You're first going to apply your where clause if you have one, a where quota if you have one, then grouping. Then you might keep or throw out overlapping groups. You might keep or throw out empty groups. Then you're going to evaluate all this stuff. Then you're going to order by. Then you might apply a having clause. Then possibly a having quota, and we'll see that right next. And then finally, this little roll-up option is quite useful as well. So let's see here. If we're interested in only the top 2 suppliers, we've sorted it now, so we can have a having quota. And I set that to 2, and we execute it again, and we're only going to keep the first 2 rows of this. And then, by definition, if you have a having clause in a query, and it's binding, you have thrown out some data. It's often useful to accumulate that data into a single row. So we can do that by setting the roll-up option to 1. And we now have a nice little other category with all the other stuff in there. And that's useful. Finally, you might want to have a totals row on this thing. So I'm going to clear a few properties of the exact same query because I don't want a quota, I don't want a group by, and I want to re-execute it. And I just get back a row of stuff here. And I want to add that row to the result of the previous query, which did it on all the data. So I have there an unformatted view of this, and then I can, of course, format it, and I get a nice little table. All right. Any questions about the? So we have a programming language. We have an object model. The object model is fully integrated with it, just like you're sitting in Dyalog and you can type a couple things and then do something in .NET or use something in the session that's an object. It's all the same. It's all the same concept. The database that's behind this, yes.
How new that was a total? Merely because you added it?
It knew it. How did it know that? For display purposes here.
Yeah.
A data table defaults to, there's something in there that it knows. It knows that it came from a, how do I know? I forgot how I know, but there's a way I know that. Now you can set any data table. A data table has a style properties, okay? And I set these things up to default to the most useful thing, and it kind of knows that, and I forgot how I do that. But you could change that, obviously, and get rid of those lines and all that stuff. The database behind this is, well, it's not behind it, it's part of the whole thing. It's just, it's one thing. Is a relational database, and it has some interesting properties. One of them is there are no destructive updates. The database stores absolutely everything. Nothing is ever deleted. And there are really interesting properties that come out of that. And there are also, in terms of implementation, it makes implementing very complicated things like multi-valued concurrency control and dealing with multi-threading and dealing with all the complicated things that a database has to do with multiple users. It makes them, if not trivial, it makes them very, very easy because you get rid of tons of issues that that can come up with any other method that can corrupt your data. The data is almost indestructible. The database is like a true functional. It exists the way when you hear John Scholes talk about the difference between procedural programming and between functional programming or declarative programming. The FlipDB database is. It cannot. There's no change to it. You can add to it, but you cannot change it. And if it has, so it has no moving parts effectively in a FlipDB database. What does this mean in practice? Well, first we'll take a little example here. I'm going to note the current date and time. So I just take the current date and time function and assign it to way back then, so we can keep track of what time it is. And I'm going to create a data table from scratch. And a data table, again, is just an in-memory representation of some data. And I'm going to add a column to it. So here I'm just building up some data that I'm going to play around with. I'm going to add, I'm going to essentially add a couple of new suppliers to our supplier table. And I'm going to assign the status 10. And I'm going to use the insert method of the supplier table to take this data and actually commit this. And there you can see the supplier table has two new things on it. And that's we could pull the plug now. I mean, that's written to disk. It's there. Now I'm going to create a new query based on this table. And I'm going to look at the data as it exists right now, which is execute with a 0 method, with a 0 argument. And that looks just like the table above, obviously. But I can also look at the table as it existed one transaction ago. So I'm saying execute this query on this data as it appeared one last transaction ago. So you can see that those things disappear. And I can also ask to execute it as it was at a particular point in time, which in this case is the same thing because we only did one transaction. So any query can be executed on any past state of the database subject to schema changes. If you've deleted columns or you've done things like that, it won't be there. But I want to note the time again. And I'm going to use a couple of other methods here of data tables to poke some values in. So I'm going to change the status on this, again, this in-memory data. This is just like a variable, really, of these two things to 90, of these two suppliers, supplier S7 and S8 to 90 and 100. And I'm going to prepare, but I'm not going to execute an update. And I call it a deferred update, and it returns something called an assignment object. And one of the neat things about FlipDB is it has something called multiple assignment. So there's no transaction wraps, there's none of this stuff. If you want to add data to one table, delete some data from another table, update some data in a third table, or all in the same table, you can construct as many transactions as you want. Transaction might be as many assignments as you want, bundle them as a multiple assignment, send it to the server, and it's an atomic transaction. So you never get any half-done work. So A1 is an assignment, and if we take a look at it, it just says that here's some data, we're going to update this table, and but we haven't done anything. It's just a set of instructions that we're going to deal with later. I'm going to prepare a second assignment with some data in it here. And this is going to add two more rows to our table. So one is doing an update, one's doing an add, or an insert. So we're going to do a deferred insert here. So now I have these two things, A1 and A2. And these are assignment objects that are going to be sent to the server in one go, to the database, using the assign method. So that was an atomic transaction. Both those things have to happen. Pull the plug anywhere, or none will happen. And now we can look at this table as it is today, and notice that we've updated the status for Hume and Locke, and we've added two new suppliers, Davis and Stone. And we can check it as it was one. If we go to the back then time, you'll notice that we not only did we lose those two new suppliers, but we've changed this. We've gone back to when the status was unchanged, and we can even go back further, of course, and see it as it was before. So we can go back in time and do all these things. What's that?
What about columns?
What do you mean? If you deleted a column, you would get an error on the query when you asked for it at that. Well, you'd get, if you deleted a column, the current query wouldn't work, and the past query wouldn't find it. So if a column is deleted, it's deleted, it's gone. The built-in support does not track changes to the schema. It's going to track just what you've got. So though it probably wouldn't be hard to you could do that. It gets messy. Right?
What was happening with the way back then, where you don't have this age, for example? What would happen if you add that again?
If you don't do what?
The last executor didn't have its 7 or its 8.
Right, they're missing because at this point in time here.
What would happen if you add them again? Because I guess they still exist.
Well, you could add if you added them again, they would actually be different. I mean, you can undelete them. Well, no, you can't. They're there. You can't add them again in the current thing. And when you go back, they're gone, but they're there. So I was confusing when you delete something, which you can do. You can delete stuff, and it never really goes away. It's all there. So. Okay, this is all useful. It's you can do some nice stuff with it. But if you can't put it up in a little pretty report, it's not. You're not going to be able to give it to anybody who has a real business need. Yes, Paul.
You've got multiple multiple rights, the two just then.
Yes.
If one of them turned out to be erroneous, you just undo one step.
Well, if one of them was erroneous from the database's point of view, like it violated an integrity constraint, the whole thing would get rejected. So all of them have to be legitimate, or it's going to kick it back out. If you decided after the fact that you didn't like the second part of that, you would have to undo the whole transaction. Or more, you would probably just apply another transaction. You wouldn't undo anything. In fact, we don't have an undo transaction. You just apply another transaction on it.
I think Rena, can you repay human log? And obviously, as things stand, they're not actually disappearing anyway. But if you did delete them, you can re-add them, but they will be a different human log.
Well, you can't add human lock because supplier name is a first. There's two issues here. One is if we look at the current Q3.execute 0, they exist. Okay. If we were to delete them, we could add them again, but they would be different. You could call them the same thing, but now you're going to get an issue of identity, and it's a little complicated. But if you would try to add them now, you would get a referential integrity error. Not a referential. You'd get it's a primary key, so it would kick it out because they're not unique. But if you deleted them, you could add them back because the only thing that stops you from adding something is if there's a primary key with that same value. Okay, so you could delete them and then add them back. So let's take some of these things and throw them into a nice looking report. We can create a report object, one of our objects. And you can display a report like anything else in the session, and it's not going to display the report for presentation, but it's going to tell you all of the styles that are in there and kind of show you any content in this report. We can create a page layout for it. We can display that. It's got a few properties that might be of interest, orientation, page size, and whatnot. Maybe set the margins. And then we add the page layout to the report. And it's treated as content. And when you render the stuff, it knows what to do with it. We can add a heading, some text with a built-in style. We could create styles too. I'm not going to do that right now. We can create a new paragraph, which is going to be in the normal style. We can add some text to it. This is the display in the session of that paragraph. It just shows you the text and what formatting might be applied to it. And here I'm just going to add a bunch of text. So we can do some inline styling where we're adding text, and we might want to just go right to some italics or bold and whatnot. And then you have to add the paragraph to the report. So now we have this thing R, which is a report object. And once reports get big, you're probably not going to display them in the session. But this shows you everything that's in this report. And I'm going to add a few more things here. I'm going to add a table to it. I can add a table directly, or I can format it and do some things in the middle. Here I'm actually going to use some methods of a report table to actually poke in some new titles because I want some more descriptive titles. So I can do things like that. Add this table to the report. So again, I'm just using this add method to just slam stuff into a report. And now we'll see if this works. We'll show the report. It's rendering the report in RTF and then just displaying it in Word. So you can do things like that. The object model is, the reporting object model is a layer above any particular output. So we could, at some point, we'll have methods to display it as PDF or really anything. Oops. I'm going to go. This was just to show a couple more things about reporting, which I don't really need to show you. Whoops. You can, of course, add new page layouts, so you can change your, just one last thing there. You can, of course, do things like that where you're going from portrait to landscape and adding new tables and doing all of that. You can pretty much do any kind of report. We've got about 5 minutes, and oops, I'm in the wrong spot here. I can show more about queries, or I could take some questions for the 5 minutes. I mean, there's a lot more little things, but we'll just do some questions. And how about Jim and then Jim?
Is FlipDB product or something used in-house? Is it shareware? What
Good question. FlipDB is not released yet. We're hoping to get a version 1 out at the end of the year, and it is the primary product that we will be selling to not replace. It's going to be a companion product to our current product for at least 5 years, and then, but we intend it to be the flagship product going forward. I've shown you one part of it. I've showed you a session. When we sell this to our customers, we're not going to show the session. They don't care about the session. They might care about it 6 months down the road or a month down the road if some programmer or some IT guy wants to know what he can do with it. There are 3 or 4 other major components. One is essentially an explorer that you actually, I think I have right here, an explorer interface to this thing, where you could see all your databases, you could store scripts, and you can do all this sort of stuff and edit data, and it's all GUI. And then there's a couple of primary, really application-specific, not application-specific, but rich GUI tools for importing and exporting and doing those sorts of things, extract, translate, and load. That's what we actually sell to the customers. But the fact that that's all based now on a formal programming language, which is logical and consistent, or at least hopefully so. And they can script this, but it's not the main sell. We're not selling the language, really, because no one wants to buy a language. So at some point, the FlipDB engine, we might throw that out to the APL community, and you could just program. It would just become as a workspace or a class or something like that, and you could use that. I haven't really, if someone wants to.
The product that you sell, this is the engine underneath CAS.
Our current product was an attempt at this when we didn't know what we were doing. But this is not going to underlie that. This is a completely separate product. Okay, and the main interface to it will probably be something along these lines, which is a graphical interface, and then from there, if you want the session, you go in there and you get the session. That's the idea. So, what's that? Well, script looks, if we go back to the Explorer, here's a bunch of scripts, and here's one here. Let's see. There's a script.
So it's essentially what you type in the session.
Yeah, that's a script. It's no different. I mean, an APL function is something you can. Yeah.
Who are you trying to sell this to? What's the target market?
Well, our target market is our current customer base, which are basically investment banks and anybody in finance, investment banks, accounting firms, commercial banks who do a lot of data analysis. Our area, I mean, where we have our contacts, is in the mortgage and securitization industry, and we have a current product which is used a lot like Excel as a standalone tool for importing, exporting, cleaning, scrubbing, and analysis of loan level information. And it's used for all types of collateral. I mean, there's no hard-coded field names. These customers are using our current product, and they have a lot of problems with it. It's not multi-user. There's not multiple tables. There's just one big table in the thing. It's not Unicode. So we addressed a bunch of the issues that they have now, have been piling up over the years. It was not as programmable. We bolted on the programmable aspect of our current product. This, we did it the other way around. We built up the programming environment and then built the thing on top. So this is all marketed at our current customer base to not only do what they're doing now, but to do a lot of the things that they've wanted us to do that we couldn't do before.
So a customer would probably just use their legacy data sources and do an ETL into this?
They could. They might do that. They could use this as a standalone. I'm using this right now as just a standalone app, okay? It's right on my PC. However, one of the big problems we're trying to solve is what happens if you have 10 people doing analysis. They need a central repository, and they need to track their projects and do all this sort of stuff. So you need a true relational database. It has to be multi-user, secure. It has to be TCP/IP, and this does that as well. So we have much bigger fish that we want to fry with this.
So if I had crystal reports and I didn't want to use the built-in reporter,
Yeah.
I could export files from that and put it in crystal or.
Sure. I mean, you could write out stuff as a in any format you wanted, or will be able to, depending on when we get to all of that. But one of the points of this thing is to not use crystal reports. If you're using crystal reports, then you're not in. So. Thank you. Okay. Thanks.